First thing you will want to do when searching is to develop search strings, which are short lists of keywords related to your topic. For example, here is a post I ran across. In less time than it took for this person to write this slightly bossy post, he or she could have used the most important keywords in this description to easily find the book. If you could only pick the most important 3 to 4 words that are most specific to this novel's description, what would you pick? Words like these are not important at all, and all books have a protagonist, so that's not really important. Of what's left, Gunrunners is probably the most specific term that sets its content apart from other novels. Tons of books have a mythology subtext, so I'll leave that out, as well as the hippies, since this person isn't 100% sure that hippies are actually in the book. My initial search string would be witchcraft, gunrunning, Native Americans, novel. This is probably the book that person was looking for, and using the keywords in the description, it really was pretty easy to find. Similarly, when searching, you'll want to develop and then refine strings of keywords that lead you to results that both seem relevant and, of course, are research quality. There is no such thing as getting a search string correct on the first try because there is no one correct search string. To understand this, it's important to know how search engines work a little bit, so let's have a little intermission from a Google search engineer.
Hi, my name is Matt Cutts. I'm an engineer in the quality group at Google, and I'd like to talk today about what happens when you do a web search. The first thing to understand is that when you do a Google search, you aren't actually searching the web. You're searching Google's index of the web, or at least as much of it as we can find. We do this with software programs called spiders. Spiders start by fetching a few web pages. Then they follow the links on those pages and fetch the pages they point to, and follow all the links on those pages and fetch the pages they link to, and so on, until we've indexed a pretty big chunk of the web. Many billions of pages stored across thousands of machines. Now, suppose I want to know how fast a cheetah can run. I type in my search, say cheetah running speed, and hit return. Our software searches our index to find every page that includes those search terms. In this case, there are hundreds of thousands of possible results. How does Google decide which few documents I really want? By asking questions, more than 200 of them, like, how many times does this page contain your keywords? Do the words appear in the title? In the URL? Directly adjacent? Does the page include synonyms for those words? Is this page from a quality website, or is it low quality, even spammy? What is this page's page rank? That's a formula invented by our founders Larry Page and Sergey Brin that rates a web page's importance by looking at how many outside links point to it and how important those links are. Finally, we combine all those factors together to produce each page's overall score and send you back your search results about half a second after you submit your search.
Because search brings back different results based on the terms or search strings that you put in, it's really important to try several different search strings, since using different search strings will bring back different results. When looking for some new resources to help me with this lesson, I used these search strings to begin with. I'm pretty much simply adding words and using synonyms to change up the search. If you have no idea what keywords to even use for your first search strings, simply Google your broad research question. Notice how Google will try to auto-predict what you're going to type based on similar questions others have asked before. It's a little creepy, but it can be helpful when you don't know where to begin. Also helpful are those first results you get when you ask that general question. The titles of these articles with terms like effective internet searching and efficient internet searching would make great search strings, and I will use them next to my search. The next step, refining your search strings, is what separates the novices from the savvy searchers. Refining is done by reading through your best results to identify specific jargon or vocabulary used by the academic writers. When I read through my research quality results, vocabulary like search operators, advanced search, Boolean operators and search strings emerged. I will use different combinations of these terms with some of my initial searching to further enhance my results. Adding the more academic vocabulary related to your topic will take you to the more academic research quality sources, which is the whole idea. Speaking of operators, you can add those to your own search to get better results. For instance, if I needed some information on Mustangs, as in our horsey mascot, and want to filter out the irrelevant results about Ford Mustangs that are cluttering up my search results, I can use the minus operator to eliminate the results that have Ford or car in them. Just put a minus in front of the words you definitely do not want in your search results. But be careful, because if a good resource said Mustangs can run faster than off-road cars, I wouldn't even get that search result because I told Google to omit any web page that had the word car on it. It's very easy to add and remove the minus operator to see if it helps or hurts your results. I have a whole list of search operators you can use if you want to acquire some black belt searching skills. You will learn best by trying multiple different search strings. When you find a great result, use keywords and vocabulary in that article to help you find the next. Remember, when searching in Google, try a lot of very specific search strings because you are searching literally billions and billions of pages. When you move to searching inside a database, you are going to need to change tactics because you're searching a much smaller pond with a much less smart search engine. A research database is a collection of published works that include things like books and journals and magazine articles. Pretty much everything you find in the database has been written by experts and checked by editors, so they are much richer sources for research quality information. And many college professors will limit you to using information only from a research database. Google and other search engines cannot search inside these databases, and databases are not free, so you'll usually access them through your public school or college library. We have a database link right here on our library page, and our passwords for access are available if you don't have a library card. The quality of Google search engine is the backbone of the gazillions of dollars it brings in, so it's truly the best search engine in the world. And they keep making it even better. Because it accounts for 95% of its profits, Google is constantly putting money into its search engine. Plus, Google doesn't have to spend any money to add the actual web pages or content to it. The web is free. In contrast, databases must pay for every single article, book, or primary source document they include. They spend lots of money on high-quality information and charge libraries money for subscriptions to access that information. Profits here are based on access to quality academic information, not ad revenue from search results. So the search engines in the databases are not a big priority, which means they are really, really basic. Unlike with Google, spelling counts in databases, and you'll need to use broader search terms. First, you're going to need to decide which database to even start in. Some are subject specific, but if your topic does not fall into one of these categories, or if you're just not sure where to start, go with the master file premier. Use one of those library logins I gave you or your own JCPL card. All databases will look and search a little different, but the first thing you will want to look for is a full text limiter if it has one. A few databases will include search results for items that are not actually in their electronic collection. These would be items that you would have to physically track down at an academic library. That's a lot more effort than I'm willing to do for most things, so I always turn on the full text limiter, meaning I only want the database search to include full text articles or items that I can have right now. These other limiters let me set date and format restrictions, but I'm not going to use any of them right now. It's just nice to know that I can later if I want to. Notice how databases default to only returning results that have every single one of your search terms in them. That's pretty standard and why you want to use pretty general search terms as compared to your Google searching. While I used really specific and long search strings often in my Google searches, I will start with pretty much the main topic, online searching. This results in some so-so search results, the best being at the very bottom of this first page. This brings me to a few more of those operators I mentioned that tend to be more effective in a database. like using quotes when exact phrasing is helpful. Putting quotes around an exact phrase of words that must appear together can narrow your search. For example, right now I am getting all of the sources in this database that happen to include the word online in the article and then somewhere else the word searching. If I put quotes around my phrase and search again, I only get sources that have these two words side by side, and this gives me better search results. Once you find a hit in the database, like this one, click on it. This is basically a citation and sometimes an abstract or summary of the item. The full text of it is over here on the left. Most databases will also let you email the source to yourself, and this permalink is what you will want to use to save the direct link of this article if you just want the hyperlink. And here is one of the most wonderful features in all databases. They will do your citations for you. Forget EasyBib. All you're going to have to do with the database is copy and paste. After you click the Cite button, you just need to find the format that your teacher wants a citation in. For instance, here's APA, which is very common in college, and MLA is later down in the list. Just make sure to copy the right format. This article seems to just be a review of a book about online searching that would be helpful for my research project, but this actual article in the database is a bust. However, if I go back to that detailed record that I first clicked on, I can see all of the subjects that were used to index this in the database. And I can pat myself on the back for pretty much acing this one, but I would never have thought to search for electronic information resource searching. So now I'm going to use another operator. Using the OR operator, I can add that to my search, and now I'll be getting any results that have this phrase in it or this phrase. This can help my results get better and better. With databases, start with really basic 1 or 2 word phrases, and then you can try using the OR operator to add additional phrases. Then start over and try different synonyms and different search angles. Add and remove quotes, and really just be persistent. Searching in a database is a lot harder than Google searching. You will get different results every time you adjust your phrasing, so be creative and approach your topic from different angles, including different databases if you're not having much luck in one, since a different database will have completely different sources in it. Let me sum this up and leave you with one more golden piece of advice. Google is great, but learn to successfully search in databases too, which is harder, so that you know how to access more academic information. And whenever and wherever you are searching, use something to keep track of your good results and what works. I can't count how many times I see students trying to locate that same great web page or great article that they found earlier, but now they can't quite remember how they found it. A basic Google Doc like this is my very first step in any research project. I keep track of the URLs that I might want to use as sources in my project, and I will make notes to myself. No one likes redoing all of their work, so take a second and keep track of what you have already done and what you have already found. Researching in depth isn't quick, but there are definitely some searching and organization strategies that you can use to make yourself and the process more efficient.